So this is part 2 of our video on the exam questions about quadratic equations. Before we got up to question 6, which was exactly halfway, so we'll do the other half in this video. Okay, so question 7, show that the left-hand side is equal to the right-hand side here. So actually the left-hand side, we've got 3 sets of brackets, all multiplied by each other. All we have to do in this question is expand those 3 brackets, and as long as we get that same answer as the right-hand side, we should be fine. Okay, if we don't get that, we've obviously done something wrong. So first of all, let's just do these first 2 brackets. So 3x minus 1 times x plus 5. So 3x times x gives us 3x squared. 3x times 5 gives us 15x. Okay, minus 1 times x just gives us minus x. And minus 1 times 5 gives us minus 5. Okay, we're going to move on to our next line and just collect like terms. So 15x minus x gives us 14x. Okay, now we're going to bring down this last bracket, which is 4x minus 3. So now we're going to multiply this bracket by this bracket. So let's start off with a 3x times by the 3x squared times by the 4x gives us 12x cubed plus 14x times by 4x. It's going to be something x squared. Now 4 times 4 gives us 16. So let's carry that 1. 10 times 4 is 40. So 4 plus 1 makes 56. Okay. Minus 5 times 4x. So minus 5 times 4 would be minus 20. And then we've got the x there as well. So we've done everything for 4x. Let's go on to the minus 3. So 3x squared times minus 3, so it's going to be a negative. 3 times 3 is 9. We just got x squared. Okay, 14x times by 3, again negative. There's going to be just an x in there. 3 times 4 gives us 12, so let's carry that 1. 3 times 1 is 30, so 3 plus 1 gives us 40 there. Plus, because we've got a negative times a negative, and then 5 times 3 equals 15. Okay, now all we've got left to do, let's collect our like terms. So we've just got the 1x cubed, one set of x cubed, which is 12. Okay, we've got 2 numbers, which we've got an x squared. So 56 take away 9, that gives us 47x squared. Okay, minus 20x and minus 42x. So minus 20 minus 42 gives us 62x, and then just the plus 15 at the end. Now all we need to do to make sure we're right, see if this answer is the same as what we're given at the top. 12x cubed, correct. 47x squared is correct. Minus 62x is correct. And plus 15 is also correct. Okay, question 8 is our first factorising question where we've got a coefficient of x squared that's greater than 1. So let's think about what we need to do here. Now when we did factorising before, we said this was our sum. And this one times this one gave us our product. So we need a number that has a sum of minus 30 and a product of 8 times minus 27. Now if we put it into our calculator, that gives us minus 216. So there's 2 numbers that add together to make minus 30. And multiply to make minus 216. Now let's think about the minus 216. Okay, what do we need to get minus 216? Now think about it as just 216. Bit of trial and error, we will eventually get to 18 times 12 is 216. Now how are we going to make that negative? Okay, it means either 18 or 12 must be negative. Okay, but if 18 or 12 is negative, so let's say minus 18, for example, gives us minus 216. Well, minus 18 plus 12 gives us 6, so that doesn't work. And if we had minus 12 plus 18, sorry, minus 6 there, that would give us 6. That doesn't work either. So actually, I'm just going to cross through that because it's probably what we're thinking, but it's not quite right. We need it to be negative as a product and negative as a sum. So actually we want one number that's going to be positive and one that's going to be negative. So this stays negative. Okay, but actually we've got a number that's bigger than 30, or smaller than minus 30. Okay, and we need to be able to make minus 30 by adding it to something else. So actually, 36 times 6 gives us 216. 36 minus 6 would give us 30, okay? But we want minus 30 and minus 216, so actually minus 36 plus 6, that gives us minus 30, and it still keeps this multiplication negative. Okay, we're going to put it into this form here. Okay, and I will show you a different way of solving this after as well. Now, the way I like to do these, we're going to put the coefficient of x squared in this middle square. We're going to put our constant here in this bottom square. And we're going to use these two factors that we found here as our values of x. So minus 36x and 6x. Now, let's have a look. What have we got in common between these two here? 8 and 6, well, that can both be divided by 2. They've both got an x in there as well. So 2x, that's going to be part of one of our brackets. 2x times what then gives us 8x squared. Now we need another x in there. 2 times 4 would give us 8. Okay, we can now fill this one in. So 2x times something gives us 6x, or 2 times 3 gives us 6. We don't need any x in there. So we know one of our brackets is 4x plus 3. Okay, and in our second one, 3 times something gives us minus 27, or 4x times something is minus 36. Either way, both of them work out as minus 9. So our other bracket is 2x minus 9, okay, equals 0. Now to solve these, there are two things we need to do. Two calculations, which are these two here. So each bracket we want to try and make equal to 0 to get our two solutions. So this first bracket, we can subtract 3 from both sides. So 4x is minus 3. Divide them by 4. X equals minus 3 over 4. Or x equals minus 0.75, however you prefer. And this right hand bracket, add 9 to both sides, so we get 2x equals 9. Divide by 2, x equals 9 over 2, or x equals 4.5. So actually those are our two solutions. I will just show you one other method quickly as well, which you might find easier. If I use a bit of plain paper here. So we said that our sum is minus 30, our product is minus 216, and so our factors are minus 36 and 6. Well, we can just split this original equation up and separate the coefficient of x into minus 36x and 6x. So if we do 8x squared minus 36x plus 6x minus 27 equals 0. Hopefully you agree that this equation is still the same as this one. Okay, however, we just separated the x coefficient. So let's have a look at this left-hand side. So what's in common between 8x squared and minus 36x? Well, first of all, 8 doesn't go into 36 a whole number of times, but 4 does. And we've got an x in both as well, so we can take an x out. 4x times something gives us 8x squared. So 4 times 2 gives us 8. Times it by x to get the x squared. Okay, 4x times something gives us minus 36. Well, that would be just a 9. Okay, on this side, what have we got in common? 6 doesn't go into 27, but 3 does. Okay, no letters on the outside either. So 3 lots of 2x would give us 6x. 3 times something gives us minus 27. So again, that's actually minus 9. We notice both sides have got 2x minus 9. Okay, so actually, one of our brackets is going to be 2x minus 9. Now, what other numbers have we got? So we've got 4x outside of here and a 3 here. Now look at this one. Our first example, 4x plus 3 was one of the brackets. So actually, all we need to do, that both the things that we took out of our two factors, okay, that's what's going to go in the other bracket, 4x plus 3. And look here, we get to exactly the same stage as we've got here. The brackets are the other way around, but that doesn't matter. Okay, so from here we can do exactly as we've done here, and we should get exactly the same answers. So whichever method you prefer, okay, some prefer one, some prefer the other, it doesn't matter, as long as you can understand how we get to that final answer. So question 9, this is where we're looking at our completed square form. So whenever we see the form x plus something in brackets squared plus another letter, okay, that means it's going to be completing the square. Now the first thing we need to remember on completing the square, okay, this part here gets divided by 2 to give us our m. So x plus 2 divided by 2 is 1, all squared. That's our starting point. Okay, so we need to actually find out what x plus 1 all squared is. So x is the same as saying x plus 1, x plus 1. Okay, and x times x gives us x squared. X times 1 equals x. 1 times x gives us x. And 1 times 1 gives us 1. Okay, so now we're saying that this is the same as x squared plus 2x, collecting our x's, plus 1. Now that's not the same as x squared plus 2x minus 8, which we had in our first question. So how do we get from our plus 1 back to the original equation, minus 8? Well, we need to subtract 9, don't we? So actually, x squared plus 2x minus 8 is the same as saying x plus 1 all squared, because that gives us this one, take away 9. So our final answer is exactly that last part there. X plus 1 all squared, subtract 9. So that's in the form x plus m squared plus n. M is 1, n is minus 9. Question 10, immediately the first thing I see is there's 2 decimal places, which means we're going to need again that quadratic formula. So let's write it out again. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're going to need that using this formula here, our quadratic equation. So minus b, so minus 17, plus or minus the square root of minus 17 squared minus 4. A is just 1. And C is minus 56, all over 2 lots of A, which is 1. So let's try and simplify that. So minus 17 just gives us 17. Okay, minus 17 squared, again, put it in your calculator. 289 minus 4 lots of 56 gives us minus 224. Because it's a minus and another minus, we're going to change it to a plus. Denominator is 2. Okay, one last step of simplifying. 17 plus or minus square root of, let's add them up, 3 or 13, so 1, 5. So now we're going to stop simplifying. We're going to pop that into our calculator with one of the equations. Sorry, I didn't need those zeros there. One of our equations using the plus, and one of our equations using the minus. And if we pop those into our calculator, our first one, 17 plus square root of 5 over 3 over 2, gives us 19.82. Remember, it's 2 decimal places. And the second one, 17 minus the square root of 513 over 2 equals minus 2.82. So our solutions, x equals 19.82 or x equals minus 2.82. Now question 11, a lot of it is just about reading this graph. Okay, we've got a little bit about plotting the graph at the end, but part A, we need to just be able to read the graph. So this line, we're told, is y equals x squared minus 4x minus 2. And we need to find solutions when x squared minus 4x minus 2 equals 0. So the only thing that's changed is instead of y, we've got 0. So where does y equal 0 on this graph? Here's our y-axis. Okay. Y equals 0 is here. So we go across. I would say that's about 4.4. So x equals 4.4 or minus 0.4. Okay, normally you get a range for your answers here. So maybe if you go 4.5 and minus 0.5, I'm sure that would be fine as well. Okay, let's have a look at this one then. So we want to make it in the form x squared minus 4x minus 2 equals something. Okay, so how do we get from minus 6 to minus 2 here? We need to add 4. So again, we've got our line. We want to find out now where y equals 4. So here's 4. Okay, and there's no harm in drawing these lines there just to guide us. I would say x equals, just be careful trying to read these, 5.2 or minus 1.2. Notice how I've just looked very carefully. Okay, here's clearly the 4. The 5's not so clear which line is. Every square is 0.2. So 5 squares will bring you to the next whole number, and then we've got 1 square further, so an extra 0.2. Okay, part B. Use the graph to find estimates for the values of x that satisfy the simultaneous equations. The top equation is the line already drawn for us, that curve. Okay, we need to plot the line x plus y equals 6. Let's do a quick table of values. So x and y. So if x is, we'll go with some negatives, minus 2. Work our way to the positives, 1 and 2. So minus 2 plus 8 would give us 6. Minus 1 plus 7, 0, 6, 1, 5, 2 and 4. Okay, so minus 2, 8. Start plotting these points. Minus 1, 7, 0, 6, 1, 5, and 2, 4. Now we can clearly see we're going to cross the curve at one point. Let's get our ruler. Let's try and be as accurate as possible. Okay, we also know that when x is 6, y is going to be 0, so it should cross through there as well. So there's roughly our line of x plus y equals 6. Now where do these two lines meet then? So we're going to say this coordinate minus 1.6, 1.7, and obviously 8 on the x-axis, y-axis. This coordinate 4.8. Just be careful here because each square is actually 0.4 this time. So 4.8, 1, 2, about 1.2. Okay, so actually our solutions are, because we've got the values of x equals minus 1.7 or 4.8. And again, you would get a range of answers that would be applicable. On to our final question, question 12. This is a classic GCSE question because people look at this, see the shapes, see some algebra and think, I don't have a clue what I'm doing. Okay, this is actually quite easy if we look at the information. So we know it's a rectangle and a right angle triangle. Okay, the key thing is that we're looking at the area of the rectangle and the area of the triangle. Okay, we should know the area of a rectangle is length times width, and the area of our right angle triangle, base times height over 2. Okay, so our rectangle has an area of 3x minus 2 times x minus 1, and our triangle has an area of x times 2x over 2. Okay, so we can expand these brackets here. 3x times x is 3x squared. 3x times minus 1 is minus 3x. Minus 2 times x is minus 2x. Minus 2 times minus 1 is plus 2. Okay, collect the like terms. These combine to make minus 5x. Okay, our triangle. X times 2x gives us 2x squared. Okay, 2x squared divided by 2, we can cancel those. Just gives us x squared. Okay, so what we're trying to say, because the area of the rectangle is greater than the area of the triangle, we're going to say 3x squared minus 5x plus 2 is greater than x squared. Now imagine the inequality sign as an equal sign for the moment. Okay, this just comes into our final answer. But let's try and find out what we can do with this. So really we want to get the right hand side equal to 0. So if we subtract x squared from both sides, okay, that gives us 2x squared on this left hand side, minus 5x plus 2 is greater than 0. Okay, so what's our next step from here then? Well, we've got our quadratic equation, it's equal to 0 or greater than 0. We can now factorise this, so we need two numbers that have a sum of minus 5 and a product of 2 times 2 here, so that makes positive 4. Okay, so we know that four and 1 are our factors of 4, or we could have 2 and 2, but they're not going to give us 5, are they? So we could say 4 times 1 is 4, but 4 plus 1 doesn't give us minus 5. To get that minus 5, and to keep this still positive, both of them need to be negative. Okay, so minus 4 and minus 1 are our factors. So I'm now going to use the grid method to try and factorise. So we're going to put our 2x squared in the middle here, our 2 on the bottom right, and we're going to separate the coefficient of x into our two factors here, so minus 4x and minus x. So let's have a look, what's in common in here and here? So minus x and 2x squared. Well, there's definitely an x. Okay, we can't have the minus because this one's not negative as well. So x times something gives us 2x squared. We need another x in there, that gives us x squared, times it by 2 gives us 2x squared. So 2x and minus 4x, 2x times what gives us minus 4x? Well, 2x times 2, sorry, not 2x. Okay, 2x times 2 gives us 4x. There needs to be a minus 2, okay, to make it negative. Minus 2 times something gives us 2. Well, 2 times 1 gives us 2. Okay, we need that to be negative to get it back to a positive as well. So our two brackets then, 2x minus 1 and x minus 2 are greater than 0. So we need to do two sets of calculations now. First of all, 2x minus 1 is greater than 0, and x minus 2 greater than 0. So we can see there from our two brackets. If we do this first bracket, okay, we can add 1 to both sides to get just the x's on the left hand side, and then we can divide by 2 to find out what 1x would be worth. So x is greater than a half. On this other side, we can add 2 to both sides, and we're left with just x is greater than 2. So we've got x is greater than a half and x is greater than 2. Now we want to find a set of possible values of x. So could x be 1 and satisfy both of these? Because 1 is greater than a half, but actually 1's not greater than 2, is it? Okay, so x is greater than 1 wouldn't work. Anything less than a half wouldn't work. So the lowest possible value of x is going to be anything that's greater than 2. So our final solution is just x is greater than 2.